Good day, everyone. Welcome to our next presentation. And we shift our focus towards the technology and tools that empower modern HR analytics. In today's organization, HR professionals operate within increasingly digital and data centric environments where decision needs to be informed not just by intuition or experience, but through structured data driven insight. This portion of our lecture aims to explore the tools, platforms, and technologies that form the backbone of HR analytics practice, from visualization dashboards like Power BI and Google Studio to advanced programming languages such as R and Python. This is Ria Alcantara. For our learning objectives, by the end of this segment, we aim to achieve several important objectives. First, you will be able to identify the core technologies most commonly used in HR analytics today, whether for data storage, visualization, automation, or modeling. Second, as we examine how business intelligence dashboards such as Power BI and Google Data Studio transform raw HR data into meaningful insights. These tools are essential because they enable decision makers to track workforce metrics in real time, visualize trends, and monitor emerging risks. Third, they will gain an introductory understanding of how R and Python support each related data tasks. These languages allow analysts to clean data, run statistical tests, build predictive models, and automate reporting with greater flexibility than Excel alone. And finally, we will review a case study and real analytics output, giving you a practical view of how these tools are used in real organizational contexts. Moving on, HR analytics technology stack. To understand how HR analytic tools support decision making, we look at the broader analytics technology stack. HR analytics tools typically fall into five core layers. The first layer consists of data sources, the HR applicant tracking system, learning management system, and payroll databases. This platform houses the raw transactional data needed for analysis. The second layer involves the data storage. Excel remains widely used for its accessibility, but for larger organizations, SQL databases, cloud storage, and BigQuery provide more scalable solution for storing, querying, and managing HR datasets. The third layer includes analytic tools themselves, which is primarily the R and Python. These languages allow analysts to perform deeper statistical tests, build predictive models, and automate complex workflows. The fourth layer includes the visualization tools such as the Power BI and Google Studio. These tools provide dashboards that allow HR to monitor hiring funnel, attrition risk, demographic diversity, and performance trends at a glance. And finally, the fifth layer consists of automation and AI capabilities. Machine learning, NLP, and predictive modeling help organizations detect patterns and risks that may not be immediately visible through traditional analysis. Now we go to the HR dashboards. Why they matter? Dashboards play a central role in modern HR analytics because they enable organizations to monitor key workforce dynamics in real time. HR dashboard uh, helps track KPIs such as time to hire, turnover rate, absenteeism, and headcount trends. They also monitor recruitment funnels, conversion, helping HR where bottlenecks occur, whether at shortlisting, interviews, or job offers. Dashboard also identify attrition risk by showing which department or demographic groups are experiencing early warning signs of disengagement. Beyond this, dashboard allow for demographic visualization, helping organization monitor diversity and inclusion metrics. And finally, dashboard enhance communication by making insight easy to share with leadership team and line managers. For the most two common HR dashboard, we have the Power BI and the Google Data Studio, or now we call the Looker Studio. Let us now look at the sample visuals from the two of the most widely used dashboard in HR analytics. Start off with Power BI dashboard. Power BI provides dynamic interactive visuals. In the sample dashboard, we see the recruitment funnel tracking candidate drop-off, a bar chart showing hires by department, a monthly application trend illustrating cynical hiring pattern, and KPI cards displaying time to hire and offer acceptance rate. These elements give HR department consolidated view of organizational hiring performance. On the other hand, we have the Google Data Studio dashboard. Google Data Studio, now the Looker Studio, provides similarly powerful visualization capabilities used for demographic insights. The sample visuals here include a gender ratio pie chart, a bar chart for age group, educational attainment, department level headcount, segmentation, marital status, and tenure. These dashboards are specifically useful for workforce planning, diversity analytics, and employee experience monitoring. I have here a link to the live version of the Looker Studio that I recently created. As mentioned earlier, HR Analytic deals with large data in order to visualize its capabilities. The dataset from this sample was from Kaggle. This is the dataset which we call as the data source directly connected with the Looker Studio. This data source comprises the needed data like the age. Where is the age? This one, the age. These are the sample data. Gender, marital status, department. We have here the department, monthly income, and so on. So this dashboard comprises pages such as demographic, this one, the demographics, the performance, where we can see performance rating from outstanding to excellent, performance rating per gender, uh, and then employee overtime rate, job role and job satisfaction of active employees, and then the work life balance. This dashboard comprises pages such as the demographic, the performance, attrition, and then matrix and visuals, which can be used for strategic decision making. So going back to the presentation, now let's dive into the importance of the business intelligence tools and their key characteristics. Business intelligence tools offer several important advantages. First is they support data centralization and connectivity. Dashboard pull data directly from multiple HR systems, removing the need for manual consolidation. Second is they transform raw numbers into intuitive, interactive visuals that allow for faster interpretation. And the third is BI tools support self-service analytics. This means HR leaders and manager can explore insights on their own without requesting reports from analysts every time. Like for example, the local studio, once it is shared with managers or the higher ups, all they need is to just refresh it, and the analyst or the staff would just feed in the the data sources daily if there are, and then all they need is to refresh that report, and then it automatically creates or updates the report, the whole dashboard. And finally, BI platform provide the real-time data access. This ensures that decision, whether related to hiring, retention, or workforce planning, are grounded in the most current information available. So let's proceed with the advanced analytics. Moving beyond Excel. While dashboard represent data visually, deeper analytics often require more advanced tools. This is where R and Python come into play. These languages allow for statistical analysis, machine learning, automation, and advanced forecasting. The slide shows various data visualization generated through advanced tool ranging from histogram to scatter plot and time series model. This example illustrates the power of moving beyond basic spreadsheet into a more robust analytical environment. For the introduction to R and Python, R and Python have become essential tool for HR analytics professional for several reasons. First, they clean and prepare HR data, which is often messy, inconsistent, or incomplete. Second, they enable analysts to run statistical tests, which can be used for performance analysis, survey validity checks, or compensation benchmarking. The third is that they support predictive models or modeling such as logistic regression for attrition prediction or random forest model for success hiring. Fourth, they provide automation capabilities, allowing HR to schedule monthly reports to generate risk scores without manual work. And finally, they offer powerful visualization libraries that can produce professional quality insights. The table of examples, which includes several applications, includes, like for example, this one, the HR task is attrition prediction. The tool uh, example to be used is the Python or R logistic regression. And then for NLP, or the natural language processing tools, for resume text analysis, NLP helps computer reads, interpret, and make sense of text like resume, emails, surveys, and chat messages. For the time to hire, estimated hiring demand, or the time to hire forecasting, the tools used is the time series model, and forecasting future hiring needs, predicting monthly attrition, forecasting headcount growth, predicting recruitment demand and staffing shortages. K-means tool is used for employee segmentation. It finds pattern and groups people based on similarities. It can be employee segmentation, high performers, high potential employee, and employee at risk of turnover. These capabilities demonstrate why R and Python are increasingly expected skill set for HR professional working in analytics roles. As we continue exploring the tools that drive modern HR analytics, we now shift our attention on the two most dominant programming languages used in people analytics today, the R and the Python. Both languages have become essential to HR analytics team, but they serve slightly different purposes and offer distinct strength depending on the types of analysis, the level of statistical depth required, and the overall analytics maturity of the organization. So why Python? Python has emerged as one of the most widely used languages in the world, not just in HR but across finance, engineering, marketing, and technology sector. One of the biggest advantages is its beginner-friendly design. Python syntax is clean and intuitive, making it far easier for HR professional and business analysts to learn and compared to many other programming languages. Python also integrates exceptionally well with Excel, spreadsheet, HRIS platforms, ATS system, and API connected HR tools. This level of integration makes Python ideal for HR department transitioning from traditional analytics to automated data-driven workflows. Python greatest strength lies in the machine learning and AI. So the such as libraries like Panda, um, scikit-learn, and Matplotlib or Plotly allow analysts to clean data, build predictive models, and visualize insight efficiently. Some of the best HR application for Python include the predictive attrition modeling, promotion probability analysis, the hiring success scoring, resume ranking, and text classification, pattern detection in employee engagement data. Python is often the preferred language when HR team wants to scale machine learning projects across large dataset. And how about R? In comparison, R is best known as the premier language for statistical analysis and academic HR research. If Python is the workhorse for industry-focused AI and automation, R is the language of scientific rigor used widely in universities, research studies, and psychometric analysis. R excels in survey analytics, employee engagement, measurement, and any HR study requiring robust statistical validation. It includes powerful libraries such as tidyverse for data manipulation, ggplot2 for visualization, and shiny for building interactive dashboard. R is specifically used for engagement survey analysis, workforce research studies, psychometric modeling, job satisfaction and motivation analysis, and climate and culture assessment. In other words, R is best when HR requires statistical precision and research gate analysis. Another comparison for the RStudio or the and the Python is presented in this slide, which provides structured comparison between the two. The R and Python overlap in many ways, but each has its own philosophical and functional orientation. Like for example, R excel in advanced statistical analysis, while Python, in the contrast, is general purpose language used across business automation, AI, machine learning, and data engineering. When it comes to versatility, uh, its versatility makes HR team to integrate analytics into broader company operation. When it comes to ease of use, R caters the statistician, whereas Python is easier for beginners and integrates seamlessly with business system. For visualization, R dominates with ggplot2, shiny dashboard offering publication quality graphics, and Python meanwhile provides flexible libraries integrated with Power BI and enterprise tools. When it comes to machine learning, for machine learning, this part uh, and AI, Python is significantly stronger. Libraries like TensorFlow, scikit-learn, and PyTorch have made Python the dominant language in industry used by 2025. From a trend perspective, this one, from the trend perspective, sorry, for the trend perspective, R remains niche but respected in academia, while Python continues to be the global standard for practical analytics and HR tech integration. Moving on to the next slide, uh, is the embedded video of the sample case study using Python machine learning. So the model is employee attrition. I will provide the link. The link of this video is also provided on the reference slide. So this is a 26-minute video, so I needed to skip some of the parts to briefly emphasize what is a typical machine learning attrition project in Python. Let's begin with the video.
What is going on, guys? Welcome back. In this video today, we're going to go through a full data science project for predicting employee attrition. So let us get right into it. For this, we're going to use a dataset from Kaggle, the IBM HR Analytics Employee Attrition and Performance dataset. Now, as far as I understand it, this is artificial data. I don't think that this reflects actual HR data. Correct me if I'm wrong. But of course, you want to apply this if you have a company onto your own company. But it's enough for this project. We're going to take a look at this data set. We're going to explore it. We're going to pre-process it. And then we're going to train a machine learning model on it to predict employee attrition. So I already downloaded the dataset and extracted it. So I have the CSV file here. And this is what we're going to work with now. Now, before we get into the code, we need to also make sure we have all the necessary packages installed. For this, we're going to install pandas, we're going to install NumPy, we're going to install matplotlib, and we're going to install scikit-learn. I think that should be it. Let me just double check my prepared code. I think that we don't need anything else. So these are the packages that you want to install, and then we're going to start by importing pandas as PD. Now, the first step is always to explore the data set. So we're going to say df equals PD read CSV, and we're going to load this CSV file here, and then we can take a look at it. Now, taking a look at it means we're going to take a look at all the features to somehow decide what we're going to do with them. Now, in order to do that, you can see I cannot see all the features here because it says ... and just looking at the column names is not really enough to understand the features and how they're structured. So what you can do here is you can say pd.options.display.max rows, and you can set this to 500, for example. And then we can look at the data frame. This will, or actually, not max rows, sorry, max columns, because we want to see all the columns, not all the rows. And this allows us now to see all the columns here. All the columns are displayed. There is no ... in between. And the first thing I always do when I explore a data set is I want to look at the features. Which of these features can be used right away? Which of them have to be pre-processed? Which of them are maybe useless and need to be dropped? Now, what I notice right away is that this here is my target variable. The attrition is what I want to predict. I want to predict a yes or no. Is the person going to leave the company or not? Attrition, yes or no. I also immediately notice that this is not a value that my model will handle right away. So this needs to be pre-processed. This needs to be transformed into a binary feature, into a 1 or 0. That's already one thing that I notice. Besides that, I see a lot of numerical features. Now, just because a feature is numerical doesn't mean that it can be used right away or it should be used right away. I don't think that this is the case in this data set here, but oftentimes you might have features, categorical features that are represented by numbers. So for example, you could have something like education field, but instead of having these words, you could have 1, 2, 5, 7, and so on, representing individual fields as IDs, so to say. So 7 could be life sciences, and 2 could be medical, and so on. The problem with a feature like this is, even though it's numerical and you can feed it into a machine learning model, it doesn't make a lot of sense to do that because it's not on a spectrum. So you're not going from low to high, because maybe medicine is 0 or medical is 0, 1 is technology, and then 2 is biology. And even though 0 and 2 are closer together in real life, they are not closer together in on the numerical spectrum here.
On the first part of what he's doing is a typical workflow that includes data cleaning and preparation. So in Python, there is a need for data cleaning and preparation. What he is talking about is that he's removing missing variable, transforming categorical variables, and preparing demographic or performance data. So he's turning categorical data to binary features in order the data to be useful in the decoding in Python. So let's go to the next part of the presentation, which is the 6:15. This one.
One hot encode. Now, what does it mean to one hot encode a feature? Let me just show you an example here as a comment or in Markdown. Let's say I have jobs and I have programmer and I have designer and I have clerk and I have maybe one more. Let's go manager. What I can do now if I have a feature like this is I can just say I have a job feature and the value is programmer, or I can one hot encode the feature, which would result in having four different features: programmer, designer, clerk, and manager, which can each be 0 or 1. So for example, I would have programmer, in this case would be 1, designer would be 0, clerk would be 0, and manager would be 0. So basically that's the idea. So this is one hot encoding of features. We're turning categorical features into multiple binary features. Of course, this only makes sense if you don't have an endless amount of different positions here, but for the most part, this is a reasonable way to do that. We're going to do that also for the marital status. We're not going to do that for the satisfaction or the income or the rate. We're not going to do it for this. This here, over 18 is a yes or no feature, so we're going to just binary encode it. Yes will become 1 and no will become 0. Over time, same thing. Yes will become 1, no 0. Then we have here again numerical features on a scale. This makes sense. This all makes sense. And these can also all be used right away. So we have a bunch. Drop it.
And the rest of the activity that he performed is he feature engineering, which is identifying the most influential factors contributing to the attrition, such as tenure, performance scores, job satisfaction, and promotion. He also did the model building and then the model evaluation, testing the accuracy, precision, call, and AUC values to evaluate predictive strength. So let's watch this part.
Value in here. So this is one I want to drop. Then we can look at all the other features here. What do I have? Over 18 also seems to be a feature that only has a single value. So this is the next one I'm going to drop. Then standard hours also seems to be 80. So if it's 80, just drop it. If it's always 80, just drop the feature. And then you can, think about all these skewed features here. But of course, since they are one hot encoded, it makes sense that most of them will be 0 and just a couple of them will be 1. But maybe you want to drop certain features here as well. All right, so what we're going to drop is employee count, over 18, and standard hours. So I'm going to say here df is equal to df drop, and I'm going to drop the list of the columns here. Axis equals 1. I'm going to drop, as I said, employee count. I'm going to drop over 18, and I'm going to drop standard hours. And now, hopefully, if I run this again, I will see only features that have at least 2 different values. Yeah, okay. So that's it for the pre-processing. Now let's go to the model training. Let's add a small heading here, model training.
This part is the model training using algorithms like logistic regression, decision trees, random forest, or gradient boosting to predict the likelihood of employee turnover.
And since this is a structure here that seems like decision making. Now, if you were to analyze this data, let's say you're an expert, you want to analyze this data, what you would do here probably is you would look at the different features. You would say, okay, satisfaction is above a certain threshold, education is above a certain threshold, the age is above a certain threshold, this is below a certain threshold, and so on. Maybe you consider the gender, maybe you consider other things, the income is that high. So with all this data, after going off the different branches of this is higher than that, lower than that, I decide that this is going to be a yes or a no. And this structure is basically a decision tree structure, and because of that, we're going to train a random forest classifier because it combines multiple decision trees into a forest, into an ensemble, and this is usually a pretty powerful model. So I'm going to say here from sklearn.ensemble, import random forest classifier, and also from sklearn.model selection, import the train test split, because we need to have a split that is going to split our data into training and testing data so that we can evaluate the model. So I'm going to say here the X data and the Y data are going to be equal to the data frame after the attrition is dropped. That is going to be our X data because the attrition is the target variable. And because of that, of course, Y is going to be df attrition. Then we want to split it into training and testing data. X train, X test, Y train, Y test is going to be equal to train test split. And then X, Y, and the test size is 0.2. Now for reproducibility, you could specify a random state, so a seed. In this case, you would always get the same result. The problem is a lot of people like to deliberately pick seeds or random states when they initialize a split or when they initialize a random forest, and then they can artificially get a good result because they choose a seed where they get a high accuracy. I don't want to do that, so I'm going to leave it up to randomness here. And then I'm going to say the model is equal to random forest classifier. I'm going to use all the cores available. So njobs is going to be equal to -1. And then I'm going to say model fit X train, Y train, and that trains my random forest classifier. Now, I can also take a look at, or I can now evaluate it and take a look at how well it performs. I can say model score X test and Y test. And this gives me right here an 86.73% accuracy, which is quite good considering that we have a 50-50 chance if we just guess. And also the data is quite skewed.
This part of the video is the model evaluation, testing accuracy, precision, recall, and AUC values to evaluate predictive strength, as he's been discussing.
Because most people get a no, so I think that this is actually, now we get 87, 83, so something around 85, I guess. Probably if you choose the right random states, you can get this above 90% as well, but that's not what we're here for, obviously. But what I want to do also here is, and I think this is the important thing, is not just having a model that does the prediction, this is nice to have, I also want to see what factors are the most important when it comes to the decision making. And random forest classifiers have the good thing about them that they show you the feature importances. So what you can do is you can say model.feature importances, and you get the values for the feature importances. Now, these are just values, these are just numbers, so what we can do is we can zip them together with the feature names. So feature names in, feature importances, and then we can display this as a dictionary, and you can see the feature importances for the different features. But even better than that would be to sort this, so to turn this into a list, and actually to sort it, and to sort all of this based on the values. So the key is lambda x x1. This sorts it by the second value in the list, in the tuple, and we do that in reverse order. And then in the end, we take all this and turn it into a dictionary. So that now gives me all the feature importances from highest to lowest. And it seems to be the case that how much a person earns per month is the most important factor when deciding if that person is going to leave the company and not be replaced or not. Age seems to be the second most important. And then you go total working years, daily rate, monthly rate. So all of these here are income related. The distance from home also seems to be important. Now, if you want to see a more visual representation of this, we can easily do that by just saying import matplotlib.pyplot as PLT, and then we can say PLT figure size is going to be 20 and 8.
Now let's proceed to the uh, 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 interpretation, which is here, the final result of the report.
Usually how much a difference is. So monthly income is the most important one. Age seems to be important, and total working years, daily rate, monthly rate, which are probably very highly correlated.
In this part of the interpretation, he is identifying which variable have the greatest influence on attrition risk. For example, in this case, it's the monthly income, the age. The top five is the monthly income, the age, the total working years, daily and monthly rates, and the distance from home. Those are the um, greatest influence for attrition in this data set.
Distance from home and so on, and then you can see the features get more and more irrelevant. Something like the role seems to be not very important. So in general, there's no role here that seems to be super important. Sales representatives seem to be either not leaving or leaving a lot. But yeah, this is how you can analyze also the feature importance, and you can now use the model for making the prediction in your company if you have a real world data set with, in this case, 83. If we do it a couple more times, 88% accuracy. This is kind of good.
Okay. So the link is provided for you to watch the whole process. The slides serve as a reminder that the machine learning projects are becoming standard practice for the HR team adopting advanced analytics. So for the final part of our presentation, is the key takeaways. So as we approach the end of this session, let us consolidate the main points covered. So the first is HR analytics fundamentally transform data into strategic decision. Instead of relying on intuition, HR team now leverage dashboard, machine learning, and statistical model to guide action. And the next one is the visualization tools like Power BI and Google Data Studio make insights accessible to leaders, allowing them to track hiring funnel performance, turnover risk, and performance demographic in real time. Programming tools like R and Python unlock advanced predictive modeling, enabling HR to anticipate risks and identify opportunities before they became organizational challenges. Real-world HR tools create measurable business impact, from improving hiring quality to reducing turnover and supporting more effective workforce planning. And lastly and ultimately, the organization that succeed in the next decade will be those that fully integrate analytics into their HR strategy and cultivate a culture grounded in evidence-based decision making. This concludes our presentation, and thank you for your attention and your engagement throughout this lecture. I hope this session has given you deeper appreciation for the technologies, tools, and methods that empower HR professional to lead strategic data-driven change. And thank you. Have a good day.